random variable. So in the past, you might recall we did things like rolling a set of dice and seeing what's the likelihood that you'd see a sum of 5 on that set of dice. And that's a discrete event. It's one thing that happens. So we'll talk something about that, and we'll use the letter X to denote the event and talk about the probability of that event occurring. And then we're also going to talk about continuous random variables. And kind of the strange thing for a lot of people when we talk about continuous random variables is that the probability of any one event occurring is 0. Because when you talk about something that's continuous, you talk about the normal distribution and you talk about the area under the curve. And remember that had a few descriptors like the area, the probability, the percent, that kind of thing. And so we'll talk about that second in our notes today. So for example, let's say you're tossing a coin 3 times, and you look at the number of heads that could be obtained. So if I'm doing this experiment, there are a bunch of different possibilities for my outcomes. I could get a tail, and a tail right in a row. I could get a tail, a heads, and a tail. I could get a tail, and a head. So those are 3 of the things that could happen. I could get a heads, and heads, head, tail, head, tail. And I could get heads, tail. Thank you. And I could get tail, heads. Did I get them all? I think that's all of them. So now if we're making a probability table for this, and I'll come back to defining the part A, but if we make a probability distribution, what that's talking about is when I talk about my table and what's occurring here, I talk about, first of all, the event called X, which I'm now going to define as the number of heads in 3 tosses. So X is going to be equal to the number of heads on 3, I guess, flips, I would say, of the coin. And then the second thing I'm going to talk about is what is the likelihood or the probability of that event occurring. So one of the outcomes that could happen when I flip this coin 3 times is I could get no heads. And the likelihood that that's going to happen out of all of our charts over there is 1 in 8. And I also could get 1 head out of my 3 flips. And that occurs once, 3 times?
Yeah.
Where's the third one? 1, 2, 3. Okay, got it. Sorry. So 3 out of 8. I could get 2 heads, and that is going to happen 3 times also out of the 8. And I could get all 3 to be heads, which is 1 out of the 8. And as I look at this table distribution here, what I notice first of all is all the probabilities are less than 1 and more than 0, or equal to, I should say, greater than or equal to and less than or equal to. And the sum of all these probabilities is 1. And you're always looking for that to see if this is an okay situation. So in our first kind of random variable, we talk about these discrete events, just like the heads and coins that we were flipping. And they define each value, each event that you talk about to be X. X1, X2, X3, denoting which event it is. And its individual probability, like flipping the heads and seeing how many you get, would be the probability for that event. So whatever the event X1 was, the P1 is the probability of that X1 event occurring. The probabilities, as we just mentioned a little bit ago, every probability that you have in your table is going to be between 0 and 1, inclusive, and the sum has to be 1. And we've talked about that before as well. couple of vocabulary things and math things that go along with these discrete random variables. We're going to talk about mean, variance, and standard deviation. So if I have that table, and I know that every event is x, like flipping one head in the 3 flips, and the probability is p, then if I want to find the mean, what I do is I take every single event, multiply it by its probability, and add it all up. So this summation sign here is talking about doing just that. Look at every event, multiply by its probability, and add it up. So these two mu's that you see here, which stand for mean of the population, are talking about finding the average likelihood that something's going to occur. In Algebra 2, if you did this, this would be what they used to call the expected value when you would talk about probabilities. If you want to find the variance of this event, that means on average how much variation is going on here, and then the standard deviation afterwards, what you're going to do is you're going to take every single event, like flipping a head, minus the mean, and square it, and then multiply by its probability. So down below, the formula is saying the exact same thing, but they're saying instead of writing every single individual piece, this piece, this piece, this piece, they just write it as the sum of all those pieces. Every individual event, subtract the mean. And then the standard deviation, all you have to do is take the square root of the variance and you're done. So 2 formulas really to remember. First one is the mean. That's every single event minus its, or times its probability, excuse me. And then the variance is every event minus the mean, and then square that and multiply by the probability. So let's take a look at an example down below. In 2010, there were 1,319 games played in the Hockey League. Imagine selecting one of those, it looks like the spacing was off there, sorry. Selecting one of the games at random and picking one of the 2 teams that played in the game. Let's define the random variable as the number of goals scored by a team that's randomly selected in a randomly selected game. And this table is the probability distribution. So first of all, we want to show that the distribution is legitimate. So when we're talking about legitimacy, they have those 2 things in the previous slide. Number 1, each probability is greater than or equal to 0 and less than or equal to 1. And then number 2, the sum of all these probabilities equals 1. That's to say that 0.061 plus 0.154 plus 0.228 plus 0.229 plus 0.173 plus 0.094 plus 0.041 plus 0.015 plus 0.004 plus 0.001 equals 1. And the probabilities, looks like the highest probability for the next part of this is 0.229. So when I make this histogram, I'm going to take that into consideration. So as I make the histogram, probably the highest probability would be 0.25 that I would need. And if I went up by 0.05, I probably could make it here 5, 10, 15, 20. So that'll work. And then for the histogram, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And looking back on my sheet here, for my first one, 0.061, Looks like I'm somewhere right about here. And then for one goal, I'm at 0.154. And then for 2 goals, 0.228. Three goals, 229. Four goals, 173. Five goals, 094. Six goals, 041. Seven goals, 015. Oh, no. 8 goals, 004.
Skewed.
Yeah, it does look skewed, doesn't it? And then the last one, 001, which is kind of hard to represent. So as we're describing what we see, one of the things we definitely see is this histogram is skewed right. Is definitely something that we see. What would you say you think is the mean or median scores? 2 or 3. Looks like the mean and the median scores are 2 to 3 goals. By the way, I probably should label down here that these are the goals scored. And this was my probability off to the left. So remember, we want to label those axes. It looks also like, so skewed right, mean. To me, it looks like if I was going to talk about something, it's unlikely that a team would score 6 or more goals. That's where it really dropped off fast. Maybe you could even say 7. That's kind of the main things I guess I see. When you talk about this next part in part C, you want to use some good notation. So you're saying what's the probability that the X, the event of scoring goals, is at least 6, means greater than or equal to 6. And then I would just write out each of the different probabilities. So in our table, that would be 0.041 plus 0.015 plus 0.004 plus 0.001, bless you, which is equal to 0.061 when you total that up.
Justine here.
And in this next part, it says we're supposed to compute the mean, that was our mu, and then interpret it in the context. Now, whenever they use the word context, they want you to talk about what they said in the opening paragraph. So make sure you just don't say this is the mean number of goals scored or any of that kind of stuff. Make sure you use a sentence to describe what's going on. From our formula, when we were talking about the mean, we know that the mean of our event is going to be each event times the probability. So we have 0 times its probability, 0.061, plus 1 goal times its probability, 0.154, plus 2 times its probability, 0.228. These are all coming out of the table. Plus 3 times 0.229, plus 4 times 0.173, plus 5 times 0.094, plus 6 times